Hello friends, today we are verifying solutions to differential equations, which is what it says on the top and you can read, so I probably didn't need to say that, but I did. All right, so basically we are given, this is a specific AP type question here, so we're given some equation with a k and we're looking for what value k, is this a solution to some differential equation that looks like that. And first, on yours, this should be equals, and so that's a little helpful, and that's a minus. It's an equals. When I highlight, it kind of goes away for some reason. And that's a minus. Okay, so the way we do this, so we have our function. Looks like our differential equation will need a y and a y prime, y double prime, excuse me. So we have to find y prime first. So the derivative of e to the 2x is e to the 2x times 2, or 2e to the 2x. Plus the derivative of k e to the negative 3x, well, derivative e to the negative 3x is e to the negative 3x times negative 3. So we end up with negative 3k e to the negative 3x, okay? Because again, it's chain rule. If we ignore the k until the end, we have e to the negative 3x times negative 3, and the k just tags along. Y double prime, 2e to the 2x times 2, which is 4e to the 2x. We'll end up multiplying by negative 3 again, so we'll get 9k e to the negative 3x. So we have y and we have y prime. So now we'll go back to our differential equation and plug stuff in. So 4y is going to be 4 times our original function, e to the 2x, plus k e to the negative 3x. Minus y prime, so minus what we just found for y prime, 4e to the 2x, plus 9k e to the negative 3x, equals 10e to the negative 3x. So obviously we got to do some algebra here. So we have 4e to the negative, 4e to the 2x, plus 4k e to the negative 3x, minus 4e to the 2x, distribute the negative, minus 9k e to the negative 3x, equals 10 e to the negative 3x. We can cancel negative 4e to the 2x, 4e to the 2x. So we have 4k e to the negative 3x minus 9k e to the negative 3x. 4k minus 9k is negative 5k. So we have negative 5k equals 10, I'm sorry, I lost my e to the negative 3x. We have negative 5k e to the negative 3x equals 10 e to the negative 3x. Divide by e to the negative 3x, so negative 5k is 10, and so k is negative 2. So what this is saying is that if k is negative 2, this function is a solution of this differential equation. I'll show you another. So here's our function. We have a differential equation. So here's y, and so then y prime. Well, we have k. Derivative of sine is cosine. Derivative of 5x is 5. Plus 2. Derivative of cosine is negative sine of 4x. Derivative of 4x is 4. So y prime is 5k cosine of 5x minus 8 sine of 4x. Y double prime, we have 5k, derivative of cosine is negative sine of 5x, times derivative of 5x, which is 5, minus 8, derivative of sine is cosine of 4x, times derivative of 4x, which is 4. So y prime is, let's see, negative 25k sine of 5x minus 32 cosine of 4x. So now we plug into our differential equation to solve for k. And it's almost always k for whatever reason. It could technically be some other constant, but it'll probably be k. So then y double prime, we have that, negative 25k sine of 5x minus 32 cosine of 4x plus 16y. So plus 16 times our original function, which was k sine of 5x plus 2 cosine of 4x. I'm going to write small and fit it, but we'll see how it goes, equals negative 27 sine of 5x. So then we can rewrite. Now it's just algebra, right? Negative 25k sine of 5x minus 32 cosine of 4x. We'll distribute our 16. So we have plus 16k sine of 5x. Distribute here as well, plus 32 cosine of 4x equals negative 27 sine of 5x. Yes, this is a bit tedious. And so then, let's see, negative 32 cosine of 4x plus 32 cosine of 4x goes away. Negative 25k plus 16k is negative 9k. So we have negative 9k sine of 5x equals negative 27 sine of 5x. We divide both sides by sine of 5x. I get negative 9k equals negative 27, so k equals 3. And again, this is saying that in this equation, if k is 3, so y would be 3 sine of 5x plus 2 cosine of 4x. It's a solution to this differential equation. I want you to try this one on your own and check your answer in the key. It's comparable to the ones we've done above. Here's another type, which if anything is just extra tedious, TBH. We actually have to test all of these. There's no real shortcut. So of the following, which are solutions to this differential equation? So we just start. We start with 2 sine of 3x. Y prime is going to be 2 sine of 3x times 3, which is 6 sine of 3x. So that's y prime. Y double prime will be 6. Oh, nope. What am I doing? I did not even differentiate correctly. You guys probably got that, right? Yep. So y equals 2 sine of 3x. Y prime is 2 cosine of 3x times 3. That's better. So y prime is 6 cosine of 3x. Y double prime is negative 6 sine of 3x times 3. So y double prime is negative 18 sine of 3x. So now we need to see if this works in our differential equation. So y double prime, which is negative 18 sine of 3x, minus 10 y prime, so minus 10 times 6 cosine of 3x, plus 9 times y, and our original function was 2 sine of 3x, should be 0. So let's see if it is. Negative 18 sine of 3x minus 60 cosine of 3x plus 18 sine of 3x equals 0. Negative 18 plus 18, so we get negative 60 cosine of 3x equals 0, which is true when cosine of 3x is 0. And this is sometimes true, but it's not true, so this doesn't equal 0 for all x, so it's not a solution. So this one's a no. Okay, then we move on to number 2. We'll switch colors to make it extra fun. So 2, we have our y value, which was 5e to the x. So y prime, this one's nice. Y prime is 5e to the x. Well, so is y double prime, right? Its derivative of e to the x is itself. So then we'll see if it works in our differential equation. So y double prime, so 5e to the x minus 10 times y prime, which is 5e to the x, plus 9 times y. Y is also 5e to the x. Does this equal 0? Well, this is 5e to the x minus 50e to the x plus 45e to the x, so that's true. So that one was quick. Now we will do part 3, or number 3, I guess, option 3, however you'd like to put that. So y equals c e to the 9x, so y prime is going to be c e to the 9x times 9, so 9c e to the 9x. Y double prime is 9c e to the 9x times another 9, so 81c e to the 9x. So now we check it in our differential equation one more time. Kind of circled it and crossed it off, but we remember what it is, right? So y double prime, so 81c e to the 9x, minus 10 times y prime, which was 9c e to the 9x, plus 9 times y, and y was c e to the 9x. Let's see if this equals 0. Well, this is 81c e to the 9x minus 90c e to the 9x plus 9c e to the 9x equals 0. It looks like we have 81c of those minus 90c, which is negative 9c plus 9c, so we end up with 0e to the 9x, so it works. So then our answer is 2 and 3 only. So that's what was correct. Okay, for this last one, try it on your own. It's very, very similar, extremely similar actually to the one we just did. Test all 3, check your work with the key.